Hi, this is Brittany, and this is my Module 6 on Moore solving equations. So, I recently taught this for the first time this year, or a unit that really involved needing to know x to the 0 power is 1, and any number to the negative first power turns that number into its reciprocal. And my students really struggled with that. One of my coworkers who teaches the same level math but has been teaching it for longer than me has a YouTube video where she explains a concept that kind of gets students to this understanding, but I didn't feel like it really stuck with them. Like, I feel like it was like oh wow, cool, I see the pattern and I see the connection between this process and the fact that these exponents create these types of numbers, but I don't feel like it really stuck with them. They still really struggle with these two ideas, and they are, as stated in our lecture video for this week, really important. So if anyone has any recommendations on ways or even tricks, I know we hate tricks around here, right? That students can that will help students really grasp these concepts, that would be really helpful. And I'll include the YouTube video that my coworker made, probably along with the link to this one. So I chose to do two problems, so I'll do this one, and if time permits, I will do a second. So for this first problem, we have the cube root of the quantity x plus 4 minus 5 equals 8. The first thing that I want to do, per usual, is that I don't want to work with any subtraction, so I'm going to change all of my subtraction to addition. And I'm also going to change my first term to its exponential form. So instead of the cube root of x plus 4, we will have x plus 4 to the 1/3 power, and instead of minus 5, we will have plus negative 5, and all that equals 8. Then I want to start thinking about what is happening to my x and in what order. So the first thing happening to my x is that we're adding 4. That's a plus. The second thing is that we are taking that to the power of 1/3. And the third thing happening is that we are adding our negative 5. So hopefully by this time, students should really have grasped the concept that if we do the inverse of these operations in reverse order, that we will end up ultimately with our x on one side. These are the steps for solving an equation, and in solving an equation, we are isolating our variable. So we're no longer going to really be focusing on doing the same thing to both sides of our equation. Instead, we're just going to do things to the right side of our equation, knowing that we will ultimately end up with an x on our left side. So we're going to do the inverse of our last operation first. So to our 8, we are going to do the inverse of adding negative 5, which is adding positive 5. And we will end up with 8, 9, 10, 11, 12, 13. I still count on my fingers. All right, and then from that 13, we're going to do the inverse of taking that to the 1/3 power, which is taking that to the 3/1 power. So we're going to have 13 to the 3/1 power, which is the same thing as 13 cubed, which if we do that in our calculator or by hand, which who is doing that, 2,197. And then lastly, we're going to do the inverse of our first step, which was adding 4, so we will be subtracting 4. So 2,197 minus 4 will ultimately give us 2,193. So x is equal to 2,193. And we can always double check our answer by substituting that value back into our equation for x and seeing that that mathematical statement is true. Next, we have this equation, negative 1/2 x minus 3 is equal to 2 minus 3/4 x. So again, I'm going to get rid of any subtraction by changing it into addition, so that way we can use all of our wonderful properties of addition. So I'm going to go ahead and rewrite this as negative 1/2 x plus negative 3 is equal to 2 plus negative 3/4 x. All right. So now we're not really isolating our, well, our ultimate goal is still to isolate our variable on one side, but now we have a variable on two sides. So we're really going to have to figure out what to do and what's going to make it easiest for us. So hopefully students are getting in the idea or in the habit of asking themselves, well, what can I do and which one should I do in order to end up with like the easiest possible numbers? Not necessarily confining them to say that there's only one way to do it, because there are several ways to do this and to approach this problem, but which one will really ultimately get you to where you want to be faster. So for me, I just chose to get rid of, or to, I'm going to do the additive inverse of my -3 on the left side to both sides of my equation. So I'm going to be adding 3 to both sides of my equation to create the 0 pair by adding it with its additive inverse. So now I am left with -1/2 x is equal to 5 plus -3/4 x. And now I'm going to ultimately move this -3/4 x to the left side of my equation, so that way I have two x terms on one side, or two variable terms on one side of my equation, and then I can combine those like terms. So on the left hand side, I'm going to have -1/2 x, and that'll be plus 3/4 x, and that is all equal to 5. And the reason that happened is because adding 3/4 x to both sides again creates a 0 pair, so that no longer adds value to the left hand side, or to the right hand side of our equation. So now I have two variable terms, and by now students should know that they can combine those like terms by adding the coefficients. So -1/2 x plus 3/4 x will give us a total of positive 1/4 x. So we'll end up with positive 1/4 x. And the way that I kind of did this in my head is I imagine that if I had -1/2, I know that 3/4, I don't know if I'm going to draw this accurately, but I know that 3/4 is made up of 1/2 and 1/4. So I know that if I'm already -1/2, then in order to get to 0, I would need 1/2 of that 3/4, and then on the other side of 0, I would need another quarter. I don't know if that makes sense. I probably could have done that with a number line, but I always imagine a pizza pie when I'm working with halves and quarters. And that ultimately is equal to 5. And then in order to create here a 1 pair, because 1 is our multiplicative inverse, and there's multiplication happening between the 1/4 and our x, I am going to have to multiply that by its reciprocal, 4/1, on both sides of our equation, and that will create our 1 pair. And now we have our x isolated on our left hand side, and 5 times 4/1 is the same thing as 5 times 4, which is equal to 20. So x here is equal to 20, and again, we can always double check that our answer is true by taking that value for x and substituting back into our equation wherever we see an x, and seeing that that makes a true mathematical statement.